Yeah, other than getting mad at the masses again, I kind of going back to this. I'm just going to use the same notation for data, and that's just this. So, both a spec or data is just going to use curly braces. I thought that was just going to be easier. We could, have some other things later on, but yeah. So right here, I'm going to just use literals, and literals are basically, again, I think I wrote it somewhere, but yeah, like empty string is just a is basically just equivalent to um, the string constructor that takes in one argument, and this is just hard coded into the compiler itself. Same as just really any number, or, decimal. These are all just numeric, and etc. Bytes as well. I'm not really sure what to do about bytes. I think I'm just going to ignore them for now. But I was thinking, at least the internal representation and compiler. Compiler treats everything as bytes and selects best representation. I think that's what I'm going to lean towards right now. So that could be a U64, for example. And this is mostly because, we can't really have, because if you have like variable length numbers, we actually do have this, right? We actually have this, but where possible, use one of U8, U16, etc. And this is just kind of how the hardware works, because your vector units and your vector ALUs and your scalar ALUs are going to be using multiples of 8. And that's generally things like 8, 16, 32, 64, 128. So that's kind of like a hardware thing. If somebody figures out how to make like a variable length vector ALU, then maybe we could do that. Or somebody figures out how to align, how to make memory less bad, less aligned. How would I describe it? How to not require alignment to be fast. Then maybe, right? And I think, CAMs and DRAM, SRAM as well, they all really have to be kind of aligned. It just kind of is just what it is. Because if you're going to be reading from multiple data banks at the same time, that's just going to take more than reading one and then applying the specific ALU width to that data unit. But, I mean, for the purposes of this kind of thing, we're really just going to treat everything as a variable length number. Later we will kind of implement this, so we have something that's not completely, bad when we get numbers like a billion and stuff like numbers way more than that actually. And we're going to assume everything is like Q64 on the local machine anyway, so more about that later. ARG, I'm not really sure what to do about ARG, to be honest. Since I'm kind of remaking all of this stuff again, array expression empty. Oh, yeah, true. Do I really want an empty? I think I'll have an empty here. Arg though, arg, I'm actually not sure about what to do here. I will concede that. Maybe I could just get rid of call for now, and we'll just focus on kind of like, let's just comment this shit out so we can focus on the actual thing. So we'll have data or function definition because that's what we're mostly worried about. And I haven't really agreed on a function definition yet, but I think I'm going to have something like closure or Rust, where, you know, you have an identifier, and then you have your arguments, and then you're, you know, piping that to a function, and you're kind of matching the slots here. Or you can just kind of do that, and what you would do is you'll force the argument list to be the same as the cold-r function list. So for now, we'll assume that so you will have a parameter list, but basically what happens is that you're basically just calling the thing on the right side with these parameters. So when I have a dot expression, I think we'll just have a an ident. Okay, I think I have to wrap that around in an array expression ident. That's the body, I guess. Okay, so and that, all that will do is that will tell us, look, you have, although I could also just change it for now too. Body, box array expression. Would I? Let's change that to ident. And just replace that with body. And all we have to do is basically match the params with the body. And the params, I said it was vex string, but yeah, because I wanted to kind of have the thing. I wanted to have a type. But I'm not really sure about that, to be honest. I think we might just rely on full type inference for now, because it's so simple. So going to comment this. I'm going to take this out. And we're going to change the way this works just to a vec of string. And the idea is to just be able to match the thing with the thing. And, you know, later on we could always add like default arguments and stuff like that too. Allow trailing. Oh, okay. Separated by comma. Okay. Data, then ignore, then literal. I think we'll fix that up too. And field we might just change to data. Or I don't know. I'm actually not sure about that. I think we can keep it. I think we can keep it. Exec args. So spec. Yeah, so here we have to kind of apply this on spec. I think we could add strings as well, because all we're doing is we only have strings or decimals. But the problem is that a certain key, right, a certain field might have a thing. So we might have to implement a field instead of spec. Yeah, I'm not actually sure about that, actually. Damn, that's really weird. It really sucks because it's hard to kind of think about this in Rust without having to, like, change a bunch of things. I've already changed quite a lot of things already to kind of come to this conclusion, or at least this intermediate premise. But I think I'm going to fix this first. Args are decimal. Are they decimal? Oh no, I'm mapping them to decimal here. Oh, okay. And I need a spec, basically. Okay. So, maybe call spec data, map arg to data. Yeah. I mean, we're not really doing eval call right now, so I don't think it's that big of a deal. But yeah, we could probably just comment this entire thing out. We could then comment some of these tests out as well. Where's the test I put? As representation. All right, intermediate refactor. So this code is quite good, right? I think it's okay. It doesn't. The problem is we do have to kind of consider like all four of them. And this shouldn't happen, but it is kind of like one of those things where it's. I guess we could have a macro for it, maybe, like a select instead. And instead we're kind of like matching that, and then we have this kind of pre-prepared, not allowed. Can we do that? Maybe it's match 2. And what you would do is that you would have each line kind of separated by that. I don't think it... Oh, it does. Yeah, it does, at least when you're, doing that thing, it does. So I guess we'll just add the comma just in case as well. Or maybe just let them do that. Panic. Would that be multiple expressions or just one? I feel like we could probably do that in just one expression. Instead of this, what we'll have is we'll have match 2. Oh, okay. Can we fuck, okay. That's annoying. So this entire thing isn't actually an expression then. I thought it might be considered one expression, since you're just, doing that. But I don't think. Yeah, we'll have to think a bit more about that if we want to do that. Then, damn, and you can see Rust is really annoying sometimes, because if you just want to, match whatever, just do it. You kind of have to think about it a bit more. In Rei, everything is an expression, so you would be able to do something like that pretty directly. Yeah, and specify more specificity if you don't want to match everything as well, if you want more control. But yeah. So we really only care about the function and stuff like that at the moment. With data, I think that's what we're doing. We're doing then literal, but I think we should also do literal or ident. But the problem with that is that we might have to return a Rei expression or a data field. I'm not even really sure about this string spec. That's one of the problems, isn't it? Damn it. Yeah, I think I can't map it to spec right away. I have to process it into a spec later. So this is one of the other things with fucking Rust. Greatest language, but for line 8. It's good that they actually give you information like that. I think I want something like that too. Okay, let me think about this. Essentially, we want data field to represent what we want, so so that would be wrong. We can't have that, I think. Or could we? Maybe we could, actually. Maybe we could. But the problem with that is also that so this is going to have a default value. So that's what's going to mean when you create something like this. You'll also have to create the default value of this. I'll probably implement this later, but I'm just thinking if it actually makes sense, because then if you have a list, then that also makes sense. List or a tuple, right? That's given that f is already defined as, I don't know, 5 or something. Yeah. So I'm not sure if I want to convert that into sugar, because I could convert that into a call, and then like we'll just treat everything like a call when we evaluate it. This is basically a call to int, so we'll process this into match literal numeric. That will become a call with int 4. That's how we would process the right hand side. And here this will just become, so another thing in Rei is that tensors are equal to tuples are equal to lists. So it's not like Python where, you know, you have like different representations. Their dictionaries are pretty good, right? But you can't just have like just 4 in your dictionary. And what this means is that it uses hashing by default. So it hashes everything in. A is hashed to A, I guess. 4 is hashed to 4. F is hashed to F. So that's kind of like how the idea of a list comes. I could probably do that, or I could go like, and for this, you know, you would hash A to 4, 4 to 5, F to the hash of this. So you will have to compute hash of default of G, then hash F to the value of the hashed value representing G. With that in mind, I think we can definitely do some things. I think it'll be a bit better. I think with something like this can represent this idea in a pretty elegant way. Searching for this for quite a while as well. I was kind of playing around with a whole bunch of different representations in Rust, and I kind of went like, okay, look, we're probably going to have an enum, probably going to use parser combinators and functions and data, but I wasn't really sure how to put the pieces together. Kept kind of like changing slightly different things to see if I can get something a bit more elegant, but I think this is a pretty good start. And for comment and empty, I mean, we're not like parsing that for now, I think, although yeah, especially since I think this will be low priority. This will be high priority. Because one of the things in Rei is that you could have, you know, just an empty function that returns something, and you just have this just in the code just randomly somewhere, right? And what this means is that you're able to just call the module itself. Like, I don't know, if you have a module called mod f a module, and then you just have some random thing here, it turns 5. You can actually just call that directly. So that's kind of one of the things I wanted in Rei. I'm not sure. I might change this later. But I think it's also, and you can. That's also a very nice way to change a class. You have a class like modules are actually the same thing as classes, I think. So that's also another thing. Modules are the same thing as classes. So if you have a class called F, classes should be uppercase, and you have something that returns F. That means calling F will kind of just work. Will just return F, and that's just kind of how you would have something that's just so very, very nicely expressive and self-contained in that one area. Charge the stuff a bit. So I think I'm going to make a function called process. Again, we're going to match, and we're going to specifically search for that a certain one, I guess. And again, you kind of just have to do that in Rust if you want something like that. If you want to use enums and variants, just you match and you skip the other cases, and you're pretty sure you're going to pass in that, and it's probably going to be okay anyway. It's not as elegant, but process data. So we want to take in an expression. We're going to match data expression, and we're going to look specifically for data field, I think. And that should return another Rei expression, specifically a call. So what we're going to do is we're going to kind of process. Every time we look at, we come across a data field, we're going to call process data. So we could even do that like during parsing, probably. And then we're going to change that into a call of that and replace the thing with the body with the body there. I'm not sure if I want to, because then we have to kind of match the body, so we have to look for either a literal ident or another data. And I think that's the bit of an issue right there, right? Because we might get another data field. I'm not really sure how to represent that, at least in this kind of syntax tree here. Especially since there's like a bunch of circular dependencies. That's kind of one of the problems with compiler design. There's probably just going to be a bunch of recursion and circular kind of ways of doing things. Later on, I'm probably just gonna still have to sort of something in because I wanted to do something else. But yeah. Oh, I actually uploaded a video earlier on. It's still processing, I think. I might have to upload it again. It's kind of sad. Can I re-upload, or I'll just delete that. I'll re-upload that anyway. But yeah, anyway, might have to just redo a bit of things. On my data, I might come across another data, so maybe I'll kind of write out some of the base cases and shit. So and I think we'll for now, we'll also have like if you want to do functions, we'll have something like Rust where you can specify the functions inside an impl block. But we haven't implemented that yet. So right now we're only dealing with data, not functions within capitalized blocks. And we're assuming that we're not actually parsing specifically for capitalized blocks, but we're assuming that all the data is going to be capitalized and that the modules are not going to be modularized, capitalized, like that. And the idea is, look, I mean, oh man. If you want to parse something like this, let me just write a bunch of things, I guess. That's not assigned to anything, so actually it's not called assigned, it's called defined. So that's not defined to anything, so it's just kind of its own thing. I think this technically just means this. I'm not sure if I want to do that though. I could do that, or I could just kind of, let's say you have like something else inside, and can it be empty? I think it can be empty, but I'm not really sure how to how would you add this, right? Would you just return a new one with just empty then? So I guess this will be the base case. And we'll also have like other simple cases, like I don't know, if you have a defined as 5 or simple case. And if you have an identifier, that means you are basically saying, look, wherever C is defined, if C is defined as, and there's no circular, right? So for now, no circular arguments. Circular fields. I'm not gonna check, but just don't use circular fields. So that means you can't just go C and C contains C. I think that would probably give me a Stack Overflow anyway. Well, I'm just gonna assume that I'm not gonna do that. Yeah. If that's the case, and essentially also like if it detects certain identifiers like int or string, will be able to instantly apply it. So if it's, unless it's like int 0, right, that's still gonna be probably parsable too. Yeah, I think that's still probably gonna be parsable too. But if you have an int a, that's probably not gonna be parsable. So that is a bit of an issue, isn't it? I'm not sure what to do about this. Assume only int literal for now, I guess. You can only call int or string on a literal, right? Then later on we'll think about how to integrate int as a more kind of function. So, and that's probably one of the reasons why you don't want to like parse it directly. So that's so you can like do stuff like that later on, right? During static analysis. So maybe I could just leave that to later on, so I don't instantly parse that. Yeah, so int by itself just becomes 0, numeric 0. String by itself just becomes string. And then we can deal with those things straight away. Then the problem is like add and subtract and stuff like that, I guess. How would you add different things together, right? So might have some checks on the types of literals. If every single type matches, we can element-wise add or sub. If not, panic. And that's kind of just how that's going to work. And later on, you know, to do that, you'll need an access modifier, so that you can access each field and then change that directly. But right now, we're mostly focused on how to convert this into this. I want to convert that into 5. Oh, and I guess we could just, yeah, we'll have that as a vector. So that would make sense then, I think. Ident B, ident C, literal. Def. So when we're doing element-wise addition, what we'll essentially do is we'll loop over that thing in that apply manner. We'll check each Rei expression if they're the same, and if they are either one of, you know, int, string, data, or literal that we can actually add. Well, it actually has to be. Like, data plus data is just empty data anyway, so that's gonna work. Literal plus literal is going to be, yeah, well, either an inner string plus an inner string. And if you have an ident, then you will have to do an indirection, and we have to process that indirection before we have to before we can do it. So we have an indirection here. We have to process this before we evaluate. Process and replace with the default of C. And we have to do that before we kind of apply that. So I think that will be fine for now. It doesn't seem to, like, great right now, but I think it's not a bad start.